Welcome dear aviation students. In today's lecture of Module 4 EASA Part 66, we discuss about the light emitting diode, which is the part of semiconductor materials. Previously we discussed about the construction of diode, p-type materials, n-type materials, intrinsic and the extrinsic materials. Now we are going to study about different types of diode. In our first attempt today we could study about the light emitting diode. Dear student, light emitting diode is a special purpose diode which emit lights of different wavelengths. Now if this LED means light emitting diode is made of this material, means to say the gallium arsenic, it would emit a light of wavelength from 850 to the 940 nanometers, and which is in the range of infrared, and its voltage would be 1.2 volt. So first we discuss about the light emitting diodes. These are the most widely used semiconductor diodes today. In every particular electronic device we have a use of this semiconductor device. Now our light emitting diodes, or LEDs, are the most widely used semiconductor diodes today. They emit fairly narrow bandwidth of energy in the form of light. LED is basically a PN junction diode. A PN junction diode made of very thin layer of heavily doped semiconductor materials like gallium arsenide phosphide. This is the gallium arsenide phosphide is the active element in the light emitting diodes. This materials means gallium arsenide phosphide determines the color of light which is being emitted from the LED. When the diode is forward biased, the negatively charged electrons and positively charged holes combines and release sufficient amount of energy to produce photon that emit lights. We discussed it again that when the diode is forward biased, means its anode is connected with the positive and the cathode is connected with the negative terminal of the battery, and it is forward bias, it would emit a particular wavelength light. The amount of photons produced emitting light is directly proportional to the current flow. Means to say that if your battery is strong, if your current flow is good, the amount of light would be much greater. The color of the light emitted depends on the wavelength, and this depends on the band gap energy of the material. In short, we could say that the color of the LED wholly solely depends upon the semiconductor material used in the LED. These are the semiconductors materials which are being used, and the color shows that what types of color it would emit in the form of light. So these are the wavelengths of a particular materials added as a active element in the LED, and these are the colors of light which is being emitted in the form of light, and this is the range of voltage drop across the different materials being used as a LED. With this, we have completed our light emitting diode. Now we are going to study about the photodiode, which is the second part of our discussion. Dear student, a photodiode is a semiconductor diode which is being used to emit, not to emit energy, but when the energy is put on this diode, the current flows. And let's discuss about it. A silicon photodiode is a semiconductor device that convert incident lights into an electric current. So this is a type of diode which when the light is put on it, current flows through the diode. Photodiodes are p-n junction diodes. Means to say there are two junctions, p-n junction. This is p and n type silicon. In which a small current is produced when photons are absorbed into the depletion region. When photon with sufficient energy greater than 1.1 electron volt strikes the diode, it creates an electron hole pair known as inner photoelectric effect. Means to say that when light strikes, due to the inner photoelectric effect, as a result, these carriers are swept away from the junction by the built-up inelectric field of the depletion region. The holes moves toward the anode and the electron moves towards the cathode and produces photocurrent. Even at the absence of light, the movement of electrons and holes produces small current known as dark current. So, the total current produced by a photodiode is the sum of dark current plus photocurrent. Dark current plus photocurrent. A silicon photodiode can be operated in photovoltaic or photoconductive mode. These are the two modes in which a silicon photodiodes can be operated. In the photovoltaic mode, the photodiode is unbiased and the dark current is at its minimum. In photoconductive mode, an external reverse bias is applied and the photodiode exhibits its fastest switching speed. This is the depletion layer between two p-type and n-type materials, and here is the p-n junction. This is a p-n junction. This is the active area. This is the particular photo of the photodiode. Look at this. We are having a diffusion mask. So with this, thank you very much for watching this video, and today we have discussed about the light emitting diodes and photodiode. One is used for emitting light when the current flows, and the second is when light is put on this diode, current flows through the diode. Thank you very much. Don't forget to subscribe our channel and comment on this video, because with this we can improve our standard and the teaching style. Thank you very much.